Okay, well, good afternoon, everybody. Welcome to the talk about logical replication of DDLs. So this is a feature that's not currently in Postgres, but there's been a lot of work happening. A lot of people for many months trying to get something working for this. And perhaps there'll be some part of this in PG17. So this talk will be about what this is all about and the status of the development work and what the patches are like at the moment. So this is a co-presentation. My name's Peter Smith. I'm a member of the Fujitsu open source Postgres team, and the co-presenter is Zane Lee from Amazon. So talk's in two parts. I'll give the introduction and we'll talk about the current state in Postgres 15 and 16, it's the same, and some problems and solutions. That'll move into the motivation for this patch in the first place. Then we'll look at the basic architecture of logical replication as it stands now and how the DDL support will fit on top of that. After the intro, Zane will be talking about the patch and how it implements these concepts. So DDL is the data definition language subset of SQL. So we're talking about the create, alter, drop operations on database objects. And so we're talking here about using publish subscribe to publish a command such as a create table command to a subscriber. So why would you want logical replication in the first place? Logical replication uses incremental messages to transfer data from the publisher to the subscriber versus physical replication, which is the full exact binary copy of the entire thing. So with logical replication, you can transfer between different versions of Postgres or Postgres on different platforms, but with physical replication, because the underlying binary is incompatible, you can't do that. So with the logical replication, you've also got a chance to just choose what you want to be replicated. So you can use a for table in schema or a for table to nominate just the tables that you want. So it's another advantage. You can also do more complicated things like subscribing from multiple publications or a single publication to multiple subscribers. But it doesn't support replication of DDLs. So that means that you need to manually set up the database structure on the subscriber side so that you've got something for those replication messages to insert their data into, and that setting that up can cause some downtime. So here's some documentation. It says the same thing, that the published tables must already exist at the subscriber side. So they not only have to exist, but they have to be exactly the same fully qualified names. So it's no good having something that's almost the same or is the same but in a different schema. It's got to be exactly the same. So one of the, you do have some small leeway with regard to columns. You could have more or less columns at the subscriber side table, and we'll see an example of that later. Now, any attempt to replicate into something that's either not there or is a mismatch, that's going to give a runtime error. And we'll see some runtime error examples. So here we've got some publisher on the left-hand side, subscriber on the right-hand side, and we create a employee table and a new publication for all tables. And then we try to create the subscription for that publication, which fails because the employee table does not exist yet at the subscriber side. So when this fails, there's no subscription created. You've got an error. You've got to fix it. So here's where we needed some initial schema synchronization to occur. If that had happened, if somebody had made sure that table existed prior to the create subscription, then it would have all gone through fine. Another example, we create a publication, same as before, and we create a subscription. This time it's good. Now it's good because there's no missing tables this time. There's no missing tables because there were no tables on the publisher at this point. But now someone creates a table and inserts data into it. Now when they insert this data, a replication message is going to be sent to the subscriber. That's going to be picked up at the subscriber side, and we see from the logs here that we get this error. Now this is an apply worker error, and the error is the same as before, saying the employee table does not exist because we haven't created it at that subscriber side yet. Now an apply worker is a special kind of process that the subscription creates. It launches to handle the incoming replication messages, and so it handled this one by saying the table didn't exist. Now when it does this, that apply worker will exit and a substitute apply worker will be launched in its place, and it'll try and pick up where the other one left off, so it'll also find that the table does not exist, and then another one will be launched to take that place, and it will have the same error, and we'll continue getting these errors until someone fixes this problem by creating that table or by just stopping the subscription or some such. So this is where we do need DDL replication. If that table employee had been replicated to the subscriber side when it was created at the publisher, then it would be already present when that insert replication message was processed by those apply worker, or the first apply worker, and it would have found it, would have worked okay. Another thing you could have done here, it wouldn't fix the error, but it would have prevented the looping of launch error, launch error. We could have specified the disable on error subscription parameter, and then the first error on that first apply worker would have caused the entire subscription to become disabled. Then the user could have gone away, fixed the table, created it that was needed, then re-enable that subscription and refresh the publication, and then it would all be good after that. So let's assume we've got some missing table and we want to fix them. So what can we do currently? Well, the first thing to look for is maybe you don't even want that table, because if you subscribe to something like a for all tables publication, then you're going to get any table that that arrives at the publisher. Is going to cause to be send a message to the subscriber. So if you don't want to get something out of the blue that you weren't expecting, you would be better to subscribe to a publication that was created for tables and schema, where the schema was all under your control, or for table publication, where you just nominate the exact tables that you want. Another problem might be that you had less columns in the subscriber side table than at the publisher side, and so that would be considered a mismatch normally, and it would fail. But if you're able to, and you're only interested in some columns, you can use a publication with a column list to limit what gets published. So in this example, we're just publishing 2 columns from the employee table, when in fact that employee table might have a dozen or more columns in it, but only 2 get published, so there only need to be those 2 at the subscriber. Now, those 2 first points are maybe not so likely. It's more likely that you just don't have the table when you want it. So in that case, you can just create the table and it's all good. Except that manual create table is only going to be any good for you if there's 1 or 2 tables. If you've got a dozen or 100 tables, then you can forget doing that. You're not going to want to. And so in that case, if there's multiple tables, then you could use the PG dump tool to dump the publisher side DDL to some file and then suck it in at the subscriber side to recreate all those tables at the subscriber side, and then create your subscription. Then it will have everything that it needs. So the point on this slide to note is that every one of these is a manual operation. The user is required to do something here. Okay, so let's say we've got our tables set up nicely. We've created it at the subscriber, at the publisher, we've inserted something into it, and it's all working well. So it's good, except it's not good because someone then can come along and modify the publisher side table. Here they've added another column to it and inserted some data. So that insert is going to cause a replication message to be sent to the subscriber to insert three columns worth of data. But notice that the subscriber has still only got 2 columns, so it's not going to know what to do with that. And so we'll get this another apply worker error, for this time telling us about the missing column. It's another one of these errors, and just we'll keep getting that error again and again. So the point to notice on this slide is that you're trying to keep up with a moving target all the time. You could have synchronized everything, but the publisher side might not be in your control, so you don't really know what's going to come next to cause an error. So this is the main motivation for the patch. If we had DDL replication, then all those user operations for creating those tables and trying to maintain them in sync could be removed, and it would look after itself. And because the DDL replication means that the tables would be created programmatically, it also gives an opportunity for some sort of name mapping that could be done immediately just prior to the execution of that DDL at the subscriber side. So Zane will give some examples about this in the second part. So the patches and the development work, you can find all the discussion and all the suite of patches. There's 8 of them last time I looked. They're all in the PGSQL hackers thread, that name on the screen there. And so I'd encourage everybody to have a look at that, get involved with the reviews or testing or anything you might like to do for that thread. There's a fair bit of backlog of posts to read to catch up. So the scope of this development work has been limited now to just DDL replication of tables, maybe indexes, I don't know the latest. There's no reason for that except to reduce it to a manageable size rather than attempt to replicate every object in the first version. And this is ongoing development, of course, so things are changing all the time. There's new patches uploaded every 2 or 3 days, so some of this stuff might be outdated by the time if you look at it next week, it could all be wrong. So here's an example of how we tell the publication that it's enabled for DDL replication. So notice that the create publication command is the same as PG15, 16. There's no change to the syntax. The only thing that's been done is a new publication parameter has been added called DDL. And in this example, the value of that DDL parameter is the types of database object that will be allowed to be replicated. And by that, I mean the create, alter, drop operations of those kinds of objects is replicated. Yeah.
Wouldn't you always want DDL replication? Why would you not want DDL replication?
Well, if something goes wrong, you'd want it back how it was before, I imagine.
Well, without DDL replication, if there's a change in the table, you'll get these errors on the subscriber. So why would you not want
It's typical with all of these
Let me give you an example.
options. Yes.
Let me give you an example. You have a big database, like, I don't know, Facebook, and you want to give a copy of your friendship relationships to the CIA. but you don't want to give any of the names. So your logical replication is going to replicate entity A, 1, 2, 3, 4, to entity B, but never mention Bob. The full name is not in the table. You can't disclose something you didn't, you can't leak something that was never in the database. So not all replication is for backup or high resiliency. Some of it is because you're giving this other entity that has a huge query load just the data they need so they can go do it on their hardware and not bother you.
Typically with these options, like the subscription parameter options or the publication parameter options, whenever new ones are added, the default tends to be if nothing, then it was as it was before. That's the case for some of the ones I've seen. But anyway, that's just an example of the DDL parameter value. In fact, well, firstly, I mean, if the that's just an example of the value. So in the second part, Zane's going to describe some. There's been a lot of discussion of different kinds of values that could take and different meanings for that DDL parameter. So you'll see more about that in the second part.
So if the target, if the subscriber doesn't have the table at all, will the initial publication create the table? Like you starting midpoint, you have a new subscriber.
We're only replicating what happens at the publishing side. So if there's no table at the publisher, then there's nothing to replicate.
Okay.
Yeah. So we'll quickly look at the logical replication architecture. There's a simplified diagram here. So on the left-hand side is the publisher, on the right-hand side is the subscriber. We can see the subscription is launching the apply worker process. Remember, that's the process that's handling the incoming replication messages. And the apply worker may also be launching table sync workers. And those are the processes that will be dealing with the initial data copy of each of the tables that are subscription members. Now, for each worker, there's a WAL sender who is sending the replication message to it. So now let's look at the publishing side. We've got the client issuing commands. Those commands are logged in the WAL. And the WAL sender, if there is one, is, well, there is one in this example, is using the PG output plugin to pull the, to read the records from the WAL and convert them into logical replication messages for sending. So let's see those steps. Here we are inserting some data, which is written as a WAL record. The WAL sender uses the PG output plugin to decode that and sending the replication message to the apply worker who applies it. Now, applies it to an existing table. Well, this is the PG 1516 example, so it has to be existing, otherwise we got all those errors we saw before. And it knows what table, because that's part of the message payload, is to tell it what table that insert belongs to. So now we'll look at how the DDL support is designed to fit on top of this. So that's the main point, actually, is that there's no change to the underlying architecture at all. It just sits on top. And firstly, we have to specify that DDL option to say that it is enabled. Otherwise, it's not with the empty default, so it would be identical to the previous slide. So when it is enabled, then the create table that the client is issuing here, some DDL, is captured and written as a new kind of a WAL record. Now this capturing phase here needs to grab every piece of useful information out of that DDL in such a way that it can write that payload data and that can be reconstructed at the subscriber end to an equivalent DDL command. So that happens in some way that Zane will describe later. And then that message is decoded and sent, same as before. Same as before, except it's just a different kind of record and a different kind of message, but same as before. and then is applied at the subscriber side. So this apply phase here is just receiving that new kind of DDL message, finding that it is a DDL message, pulling the payload out of it, reconstructing the DDL command at the subscriber side, and executing it. And so that's the full 1, 2, 3, 4, 5 logical replication of DDLs there. The last point is mentioned before, if there was some kind of name mapping, this is where it would happen. So during the reconstruction of the DDL at the subscriber side, some of the content of the payload could be tweaked, and the DDL could be slightly different. So maybe you could rename the table or something and bypass those restrictions of the PG15 that says must be exact full qualified names. So that is the end of the introduction. And next, Zane is going to describe exactly how the patch implements these different numbered phases and some of the design decisions about how it does that. So thank you very much, and hand over to Zane now.
Thanks, Peter. Hi, everyone. My name is Zane Lee, and I'm from AWS RDS open source team. So in part 2 of this talk, we'll dive into the details of the implementation, some of the design choices that we need to make, and some of the special cases we need to handle. So first talk about how do we define replication granularity? Then how do we capture DDLs? What kind of logical logging format we can use? And some of the caveats we need to do before apply the DDL at the subscriber side. And in the end, we'll also take a look at 2 related issues, global commands replication as well as initial schema synchronization. So Peter have mentioned that we use a new publication parameter, the DDL option, to enable DDL replication. So here, we really want to allow fine-grained DDL replication granularity, as we just discussed. That depends on the use case. The user may want to replicate all the database objects or only certain kinds of database objects. So, so currently, we allow this fine-grained replication granularity through the DDL option. For example, now we allow the DDL replication to be defined on tables and indexes, or only on tables or index commands. So as you can see, this in the future, we can expand the syntax to support replication of other kinds of objects like function commands and trigger commands, etc. So not only is this intuitive for use case point of view, it also actually helps with the development. It helps us to develop the feature in multiple stages based on the individual replication granularity. But we choose to start with table and index just because these are the most common commands. So in order to replicate DDLs, we need a mechanism in place in order to capture DDLs when they're getting executed on the publisher side. So here we have found 2 approaches. The first one is to inline, meaning in the execution code path of the DDL commands itself. So this would be mainly in the process utility slow C function. So the benefits of this method is that we can capture any subsets of DDL commands, and it's a relatively small amount of code change. But we do need to handle some edge cases, and which may cause some code scattered out in the execution function of specific DDL commands. The other approach is to use event triggers So this is an existing mechanism to capture DDLs. There are also folks out there that are already using event trigger for various purposes. But it should be noted that event trigger is only supported for a subset of DDLs. So if we want to support a wider set of DDLs for DDL replication, we'll have to expand on the current support for event triggers. The other benefit of of event trigger is that the new code change is somewhat containerized, right, in the DDL in the event trigger support. So in our current patch, we use event trigger to capture DDLs. So here is an example. Let's say we do create publication for all tables with DDL enabled for table commands. Then we do do a select from PG event trigger catalog, and we can see that there are 4 event triggers created in conjunction with the create publication commands. So if you notice, all these event trigger names have the same suffix. This is actually the OID of the publication. So imagine we create multiple publications, then there will be multiple sets of such event triggers getting created. So the second column is the event type that each event trigger will fire. The first event, table init write, is a new type of events that we introduced in order to capture this special commands, create table as, and and select into just after the table schema have been created, but before the data population happens. The remaining 3 events are existing events in PG15, and we use this to capture the normal create table, order table, job table commands. Yeah, so the third column is just the command tags each event trigger will fire. When the user do a job publication, and the event triggers got dropped as well. So upon capturing a DDL command on the publisher, inside the trigger function, we'll need to wall log the DDL commands, and which can later be used for logical decoding and transfer to the subscriber and for replication purpose. So, so for the new world record, we introduced a new world record type here called for DDL message. It's called xlog logical DDL message. So in this new world record, we have metadata such as the database ID, the table ID, and the type of SQL commands. So these are information that's needed during the logical decoding phase. And then most importantly, we have the payload part. And next we'll talk about the payload part. So we need to pick a certain logical logging format for the payload part so that we can fully reconstruct the commands on the subscriber side. So we've been debating on two methods. The first one is to simply use the command string. As you can imagine, this is simple to implement and quite lightweight. However, because not database object in the command are schema qualified, then during the apply, we'll have to force the original search path on the subscriber. This may have some security concerns. And also, it's not easy to support name mapping or schema mapping in this approach. Also, it doesn't allow easy machine editing of the command. If there is, for example, if we want to address certain syntax difference between the publisher and the subscriber. Well, the other method is to use structured format, maybe generated by the parsing utility. So this is more powerful and flexible And in the same time, it's more heavyweight. And in the process of forming the structured format, we can fully qualify database objects in the DDL commands. So, and this allows us schema mapping as well as command editing, which we'll see an example next. However, the downside is this adds to tremendous development and maintenance burden, and adds a lot of requirements for test coverage. So here is an example for how the DDL deparsing works. So let's say we have the DDL command alter table T1 add a column C3 of integer type. Now the DDL deparsing utility works by trying to construct a JSON document, right? What it first does is to append a format element into the JSON document based on the type of the command. So here the format string would be alter table %identity subcommands. So this is a sprintf-like string where we have some specifiers. So next in the commands, in the documents, we'll try to fill out each specifier so that we can use the format string to fully expand to an executable DDL commands. So the first specifier is the identity specifier, which identifies the database, the table in the database. So here we have two fields for the identity specifier. The first is object name, which is T1, and the schema name. So this information can, in order to get all this information, we need to consult the parse tree as well as the system catalog. And as you can see in this process, we actually qualified the database object or the table. So the second specifier is subcommands, which is actually an array of strings, the %s, meaning this is a string, but it's an array here. In this case, there's only one subcommand, which is the add column subcommand for the alter command, parent command. And so similarly, we'll have the format field, right? And we try to fill out the specifier, which is percent definition. So this process goes on and on until we have fetched all the information needed in order to fully represent a DDL command. So it's a recursive process, as you can imagine. I'm not going into too much detail here. So this JSON document will be transferred to the to the subscriber site, and then it can be reconstructed into a fully executable DDL command. So we have mentioned one of the main advantage of using such a structured format is that it enables machine editing to support things like name mapping. So how that can be done is before we reconstructing the DDL commands, we can edit this JSON document. For example, if the user wants to map the schema public to schema S1, we can find all the fields for schema name that matches public and replace that with S1 here. Then when we reconstruct the command, we'll get alter table S1.T1 instead of alter table public.T1. So apply DDL. We have mentioned that we'll reconstruct the DDL commands from the DDL message, specifically from the JSON document that's extracted from the DDL message. In this process, we can perform schema mapping if needed, as well as do any transformation to auto-resolve syntax incompatibility. However, there are also some other caveats before we during the apply process. For example, we'll automatically run alter subscription refresh publication after any create table commands. The purpose is that any data change on the new table can just replicate automatically without any user intervention. Because today the user does need to run this command even after creating the table on the subscriber side. Thirdly, by default, the replicated object or the table will be owned by the subscription owner, right? And it's reasonable that the user may want to keep the original owner from the publisher. So there is an opportunity for ownership mapping here. And actually in 16, there is a new subscription option called run as owner, which is actually the exact same idea here. But we can actually have an ownership mapping as well. For example, the user want the ownership on the subscriber to be other kind of users instead of the original user. So there is an opportunity for a new subscription ownership, subscription option for ownership mapping here. So on the high level, this is how we currently implement DDL replication in the patch. We'll capture the DDL use event triggers, and inside the event trigger functions, we'll deparse the DDL commands into JSON string or JSON blob and append that to the wall record, which gets decoded and sent on the wire to the subscriber. Then we reconstructed a SQL from the JSON data. In this process, we can do certain transformation or mapping if needed. And then the apply worker will execute the command on the destination database. Now we'll take a look at a few special cases we need to handle. The first one is, what if the DDL commands references database objects that are not replicated, meaning they are not on the subscriber side, right? So for example, we have this job table command where the second table to be jobbed doesn't exist on the subscriber. So if we were to just replicate this command over and execute it, it will get an error because the table doesn't exist. Now what we do in this case, we'll transform the commands to be logged into job table if it exists on the publisher side, and then we'll log the command and transfer it over and apply it. The second type of special case is the commands will perform both DDL and DML. Such commands include create table as, select into, as well as alter table with a table rewrite function. So for this kind of commands, we need to guarantee that the data is consistent between the publisher and subscriber. And we'll look at more details in the next slide. So it should be noted, this is not a full list of special cases. So for create table as select or select into, for example, create table T2 as select ID name from T1. So this command works as first creating the table schema T2, then it will actually populating the table with existing data from T1. So the idea here is that we want to warlog and replicate only the DDL parts. So we'll transform these commands into a simple create table command with the full column definition and warlog this new command. Then we'll let the data population happen with the existing DML replication. So, okay, right. So maybe I speak too fast here. So the problem with executing this original command directly on the subscriber is that it's possible that T1 doesn't exist on the subscriber, in which case you'll get an error. Or even if T1 exists, the data of T1 may not match that of T1 on the publisher exactly. So by doing it this way, we'll make sure that the command can be executed successfully, and the data we get is actually from the publisher. The last type of special case is the alter table command with the table rewrite function. Here, alter table DDL test add column B int default random. Well, the first proposal is don't replicate such commands, especially if the volatile function contains things like DDL itself, which may cause us to potentially replicate a DDL multiple times. In which case, those functions are actually not replication safe. So if we allow the user to, let's say, flagging the function to be replication safe, then we can try to replicate such commands by separating the DDL change and the DML change. Yeah.
Why is that not safe?
For this one, it's probably safe. It's safe. I'm talking about other kind of functions.
Okay.
Yeah. So for example, let's try to replicate this commands here. Let's say we have the table DDL test on the publisher and subscriber, but on the subscriber, you have an extra row with the value 3. Then we run the auto table commands on the publisher, and this table becomes like this with the random data populated for the new column B, and we'll replicate this command over. So the subscriber looks like this. Notice that the random number are different because it's a volatile function. Then we'll let the updates on the publisher also replicate to the subscriber. Then the final view of this table looks like this. So only the third row looks different, which is fine because the third row doesn't exist from on the publisher in the first place. So I guess the key idea is trying to separate the DDL and DML part and let the DDL part replicate first, then let the updates replicate, right? So that's this is why we introduced a new event trigger event in order to capture this type of commands at the correct place. So for testing, we have added testing for DDL replication using the TAP framework. Another big part for testing is we're adding a new module for DDL deparsing utility testing. So we're trying to test that the DDL output is actually expected. The reconstructed DDL commands are expected, and also we're testing that the reconstructed command from the JSON command from the JSON string can be executed, and it has the same effect as the original command by comparing the results from pgdump. Well, next we'll quickly go through two related issues. First one is global commands replication. Second one is initial schema sync. Global commands are also utility commands, but they're different from other DDL commands in that it manages global objects, which are accessible from different databases. So commands global commands includes database commands, row commands, tablespace commands, grant row commands, and grant and revoke on global objects. The difference here for global commands is that they're not captured by event triggers, because event triggers define per database. So the current mechanism of the patch doesn't work for global commands replication. Also, global objects are not schema qualified, so we may not need to use the deparsing utility. and also the current per dB replication model, which we just showed in the diagram, isn't really ideal for global objects replication. We probably need to introduce a new shared database replication model and catalog for replication of global commands. So this would be a future work. The other related issue is initial schema sync. Peter have mentioned that the initial schema has to be set up manually on the subscriber. So it would be an improvement if we were to automate the initial schema synchronization process. Some of the issues we need to solve here are, how do we get the schema definition on the subscriber for all the database objects that's on the publisher? We could probably utilizing some of the code in PG dump. And the second problem is, how do we probably handle concurrent DDLs while we are in this synchronization process to making sure everything actually end up consistent. So this is also being discussed in a different hacker thread, initial schema sync for logical replication. So to summarize, we have talked about the motivation of DDL replication, and we looked into the details of the implementation regarding replication granularity, how we capture DDLs, and what kind of logical logging format we can use, and some of the issues we need to know during the apply of DDLs, and some of the special cases. We also look at 2 related issues. All right, thanks everyone for attending, and take questions if there's any. Any questions? Yes.
I'm assuming, and I might be wrong about this, that in the PSQL client, where there are the commands to display the source form or something, typically like a function, that deparsing is being done in PSQL by doing catalog queries.
So it's not a PSQL function. It's actually going to be a core function or maybe an extension in the country directory. Is that?
So the work that you're doing, of course, happens in the backend.
Yes. Yeah.
And so I don't know if I'm right that what the front-end client currently does is built into the front-end client. But so it sounds as if the deparsing facilities you're adding in the backend might be useful if they're available for other purposes than just logical replication. There might be a
Oh yeah,
available there. But
yeah, definitely. I've heard people use JSON data for heterogeneous replication across different kind of database engines. Yeah, so it has other use cases. Yes.
So that was very interesting that you did decide to use JSON across that interface. And so what is there it sounds almost like you're going to wind up with a DDL interoperable specification written in JSON. I guess you might want one between Postgres versions. But as you said, you can do replication across database vendors.
I mean, that's a potential use case of that, but it definitely requires a lot of work to make it actually work, I think. And the reason we are using the JSON format is actually Avaro pointed out us to this previous work that he has done, trying to build in the deparsing utility from a few years back. So we are rebasing his work for DDL replication purpose. So you can find his slide, the old thread here, deparsing utility commands. I think it's in 2015 and earlier. Yeah.
Well, I think that's something that like Oasis or someone else might actually be interested in publishing as a standard at some point. And it has the advantage that as we move forward with Postgres, right, you deploy new versions of Postgres in a hitless fashion so that I now can replicate upward to the new version, right?
Right.
Get it all working, kill the old machine, right? And so having it in a standard format is very cool. And also then we get into the cases of somebody thinks some other
Mm-hmm.
database is cooler for their application, and we need to send the data, right?
Yeah, you just mentioned one of the probably one of the most important use case for cross-major version upgrades, trying to minimize downtime using logical replication. But it's interesting that you mentioned we could probably make it a standard. Yeah, it would be cool if every database can generate a DDL replication representation all in JSON, right? Then.
But it looked as if one of the slides you put up, you were developing a JSON. It looked almost like a JSON schema sort of spec of what you were designing.
Yeah. Okay. JSON schema. This one here? Yeah. So what was the question?
I am not as familiar with the schema languages that the JSON community has come up with. I've seen more of XML schemas, but that looks like it could be, it suggests, at least to my mind, a schema for your JSON messages. And
JSON schema is about describing JSON
Documents.
documents.
Exactly.
Right.
But these are JSON documents that are going to be produced by this deparsing utility and sent to something and used. So a schema for those documents is a useful thing to have. And that's exactly the kind of thing that you could consider standardizing. So that even though like some other competing database might not have native facilities for generating or using these JSON messages, you would still have a standardized schema that you could use if you wanted to take this JSON message and develop something that would apply it in a different database.
Okay, that's a good point. The schema, we'll look into that. Yeah. Yeah.
You mentioned replicating different types of DDLs, starting with your index, but you also mentioned wanting to replicate functions. How would that integrate with the schema mapping functionality?
Will that be integrated with schema mapping? Is that question? Yeah, we could do that, but that would be we're not doing that as in the first implementation. The problem is the patch keep getting larger if we try to incorporate more commands. So we're trying to minimize the size now. Yeah.
Problem with that is you end up having a JSON format describing the whole language.
Okay, I think I'll give.
What I like in this law is that you included sort of a place for an explicit schema adaptation step. Like you've got that, the last place, you've got a place to put the logic to adapt the schema. Like you start to see similar things for microservices. You have like some of the where formats. I think there's Avro where you have a schema registry store where you define the translation rules to go between different versions of the schema. Have you looked at any of maybe other wire formats that?
Yeah, I think I've read something along that line. Right, we haven't really looked into. Right, so I think to reiterate the question is there are some tools out there that will keep cross-version compatibility by keeping the by using the JSON schema, right? Is that right?
JSON schema or other, not necessarily JSON, but like there's different protocols for communication.
Right.
And I've seen where some of them include the ability to define schema migration rules for the client. So you basically have where I think Avro had something like this with like a schema registry. You say you're going from this version of schema to this one. This is the adaptation you do on
Right.
Yeah.
Yeah, I think that that definitely has something to do along the line if we want to do transformation.
Yeah.
Right. Yeah, thanks. We haven't really looked into that yet, but yeah, that's a really good point. There are probably existing projects out there that we can learn from. Yeah.
Like you've already made provision for adapting the table name from the publisher to the subscriber. I was wondering, there was an earlier example of doing a publication from certain tables to another entity where they had a different load of different kinds of queries. And so maybe you would want to adapt some of the table, I don't know, storage options or index settings or something. And you could apply the transformation too as a general transformation of that JSON message.
Right. So enable user to do arbitrary transformation. If that would be very cool to have, but it's also, I guess, introduce a lot of issues. Yeah.
But you're planning for, like, instead of having a perfectly standardized schema that's not allowed to change, we know it's going to change. We're going to give ourselves a place to put the adaptation. We're giving clients adapt data as they need.
Okay. Yeah, I guess we can talk more after this session. It's almost time for the next one. All right. Thanks, everyone.